When dealing with multiple services in a mixed-use building, several key electrical code requirements come into play, particularly concerning conductor sizing, neutral requirements, and grounding. Let's delve into the specifics based on your situation. Firstly, regarding conductor sizing for each meter, you will need 350 kcmil copper conductors rated for 310 amps at 75 degrees Celsius for each of the 2 meters serving the upstairs apartments. You cannot combine the loads and recalculate for smaller total demand because the apartments are served by separate meters. Each meter must have service conductor size to handle the calculated demand load for that specific apartment. Secondly, addressing the neutral conductor size, you must use a number 1/0 copper conductor rated for 150 amps at 75 degrees Celsius for the neutral. The neutral conductor must be sized to carry the maximum unbalanced load, which in this case is stated as 69 amps. However, the minimum size is determined by code requirements based on the service entrance conductor size. Thirdly, concerning conduit size, you will likely need 2.5-inch conduit unless you can reduce the size of the shared entrance conductors based on revised calculations. Conduit fill calculations must adhere to the National Electrical Code. The specific tables in Chapter 9 and Annex C of the NEC will dictate the allowable number of conductors within a given conduit size depending on conductor type, insulation, and other factors. Moving on to the grounding requirements for the two 200 amp disconnects located beneath the 2-gang meter base. Since you are not permitted to land any grounding conductors in the meter itself, you must land them in the disconnects. If the water pipe is near the service, you have the option of using either a single number 2 copper conductor with taps to each disconnect, or separate number 4 copper conductors for each disconnect. The choice depends on the specific installation requirements and available space. The NEC dictates the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. Finally, with the downstairs retail space having its own 200 amp service with a separate service entrance, with the head and service drop due to the high leg delta system for the existing 3-phase air conditioning unit, the disconnect is located inside the building, back to back with the separate 3-phase meter. In this scenario, it is permissible to run a single unbroken number 6 copper conductor from disconnect to disconnect to disconnect and then to the driven ground rods. This conductor serves as the grounding electrode conductor connecting all grounding electrodes to the service equipment. Here are some additional points to consider to ensure compliance with the National Electrical Code and best practices. Firstly, conductor ampacity must match or exceed the calculated load. Conductor ampacity is determined by NEC Table 310.15. The appropriate table depends on the conductor's insulation type and insulation conditions. Ensure you are using the correct table for your specific conductors. Secondly, when dealing with multiple services, carefully manage neutral and ground connections. The neutral conductor carries the unbalanced load, while the ground conductor provides a path for fault current. Improper connections can lead to dangerous situations. Thirdly, conduit fill calculations are critical. Overfilled conduits can lead to overheating and insulation damage. Use the appropriate NEC tables to determine the maximum number of conductors allowed in each conduit size. Fourthly, ensure all grounding electrodes are properly bonded. This includes water pipes, ground rods, and any other available electrodes. Bonding ensures a low impedance path for fault current. Fifthly, use appropriately sized overcurrent protection. Circuit breakers and fuses must be sized to protect the conductors they feed. Overcurrent protection devices must interrupt fault current safely. Sixthly, consider voltage drop. Long conductor runs can result in significant voltage drop, which can affect equipment performance. Size conductors to minimize voltage drop. Seventhly, label all equipment clearly. Proper labeling helps to prevent confusion and ensures that maintenance can be performed safely. Eighthly, use appropriate connectors and terminations. Connectors and terminations must be rated for the conductors they are used with. Improper connections can lead to overheating and failure. Ninthly, inspect all work thoroughly. After installation, inspect all connections, conductors, and equipment to ensure that everything is installed correctly. Tenthly, document everything. Keep detailed records of all calculations, conductor sizes, and grounding arrangements. Documentation can be helpful for future maintenance and troubleshooting. Here is some additional information about grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic parts are at the same potential. The NEC specifies the requirements for grounding and bonding in Article 250. There are several types of grounding electrodes, including water pipes, ground rods, and concrete encased electrodes. The grounding electrode conductor connects the grounding electrode to the service equipment. The size of the grounding electrode conductor is determined by NEC Table 250.66. Bonding jumpers are used to connect metallic parts to the grounding system. The size of the bonding jumpers is determined by NEC Table 250.102. Ground fault circuit interrupters, or GFCIs, are required in certain locations such as bathrooms and kitchens. GFCIs protect against electric shock by detecting small amounts of current leakage. Arc fault circuit interrupters, or RFCIs, are required in certain locations such as bedrooms. SIs protect against fires by detecting arc faults. Surge protective devices, or SPDs, protect against voltage surges caused by lightning and other events. SPD should be installed at the service entrance and at sensitive electronic equipment. Here is a more detailed breakdown of service entrance conductors. Service entrance conductors connect the utility power to the building's electrical system. The size of the service entrance conductors is determined by the calculated load. The NEC specifies the requirements for service entrance conductors in Article 230. Service entrance conductors can be installed overhead or underground. Overhead service entrance conductors must have adequate clearance from buildings and other objects. Underground service entrance conductors must be protected from damage. Service entrance equipment includes the service disconnect, overcurrent protection devices, and metering equipment. The service disconnect is used to disconnect the building's electrical system from the utility power. Overcurrent protection devices, such as circuit breakers and fuses, protect the conductors from overloads and short circuits. Metering equipment measures the amount of electricity used by the building. Here are additional details regarding conductor types and insulation. Conductors are available in various types and sizes. The type of conductor is determined by its insulation and application. Common conductor types include THHN, THWN, and XHHW. THHN conductors are commonly used for general-purpose wiring. THWN conductors are suitable for wet locations. XHHW conductors are suitable for high-temperature applications. Conductor sizes are specified in American wire gauge or AWG. The smaller the AWG number, the larger the conductor size. For example, a number 12 AWG conductor is smaller than a number 10 AWG conductor. Conductor insulation is used to protect the conductor from damage and to prevent electrical shock. Common insulation materials include PVC, polyethylene, and rubber. The NEC specifies the requirements for conductor insulation in Article 310. Conductor derriting is required when conductors are installed in certain conditions, such as in conduits or near heat sources. Conductor derriting reduces the ampacity of the conductor to prevent overheating. The NEC specifies the requirements for conductor derriting in Article 310. Here is some additional information about conduit and raceway systems. Conduit and raceway systems are used to protect conductors from damage and to provide a pathway for wiring. Common types of conduit include EMT, PVC, and rigid metal conduit. EMT, or electrical metallic tubing, is a thin-walled conduit commonly used for indoor wiring. PVC, or polyvinyl chloride conduit, is a non-metallic conduit commonly used for underground wiring. Rigid metal conduit is a thick-walled conduit commonly used for industrial applications. The NEC specifies the requirements for conduit and raceway systems in Chapter 3. Conduit fill is the percentage of the conduit's cross-sectional area that is occupied by conductors. The NEC limits the amount of conduit filled to prevent overheating and damage to the conductors. Conduit fittings are used to connect conduit sections and to provide access to the conductors. Common types of conduit fittings include couplings, connectors, and elbows. Pull boxes are used to provide access to conductors for pulling and splicing. Pull boxes are required when the conduit run is longer than 100 feet or when there are more than 390-degree bends in the conduit run. Here are some important safety precautions to remember when working with electricity. Always disconnect power before working on electrical equipment. Use properly insulated tools. Wear appropriate personal protective equipment, such as safety glasses and gloves. Never work on electrical equipment in wet conditions. Follow all applicable electrical codes and regulations. If you are not qualified to work on electrical equipment, hire a licensed electrician. Electrical work can be dangerous and should only be performed by qualified individuals. Remember to always prioritize safety when working with electricity. And finally, ensure that your work is inspected by the local electrical inspector. The electrical inspector will verify that your installation complies with the NEC and local codes. The inspector will also ensure that the installation is safe for occupancy. Obtain all necessary permits before starting any electrical work. Permits are required for most electrical installations. The permit process ensures that the work is reviewed by the local authorities and that it meets the required standards. By following these guidelines and adhering to the National Electrical Code, you can ensure a safe and compliant electrical installation for the multiple services in your mixed-use building.